are picking up where we left off yesterday in lesson 7-6. So we should be able to get through this and get you guys some work time here at the end of class. As we look at example 3a here, 4e to the 2x plus 2 equals 16. So different than the ones we were solving at the end of class yesterday. At the end of class yesterday, everything we solved already had a log in it. And when it already had a log in it, we were able to use left, right, middle to get out of there. Now, this one instead is an exponential equation. Okay, we solved exponential equations back in lesson 7-5. It's just a slightly different version of it. Guesses on the first step. Subtract 2 over. And why is it not subtracting 2 over? What's my goal by doing that? Okay, isolate the x. So specifically, I'm going to be a little more specific there and say let's isolate the e to the 2x. So that x is part of the e. That e is the base. So we're going to isolate that base that has the power with the x. So if it's 4e to the 2x plus 2, we need to subtract 2. If we subtract 2 on the left, subtract 2 on the right. So 4e to the 2x equals 14. Yes? No one saw that, right?
I think what happened?
Okay. Is my e to the 2x isolated? Is it by itself? No. What else do I need to move? The 4. How do I move the 4? Since it's 4 times that e, we're going to divide by 4. So now, e to the 2x equals, okay, 14 over 4. What's another option? Reduces to 7 over 2. Or, as a decimal, 3.5. Now, I'm happy with any of them. Based on the fact that this is going to have to go in my calculator later, I was going to do 3.5. I know, I actually went decimal. It's unheard of, right? Okay. But my reasoning is, and part of it is because I know where we're headed with this, and eventually that's going to go in my calculator, and so it's going to be easier if it's in decimal form. But if you leave 14 fourths or 7 halves and you use that, you'll be just fine. Okay, guys. So, we got the e to the 2x by itself. Thoughts on the next step?
Left, right, middle.
No, left, right, middle. I'm going to put it back into the log.
Okay. So, left, right, middle, we use when we're going from log form to exponent form. Now, if you want to go, like Xavier was saying, backwards and undo that to get back to log form, you could do that. And that is an option. I'm going to do something slightly different. However, if you do that and you get back in log form, you'll meet me in the end just fine. Okay? If you think back to lesson 7-5, when we had an exponent equation like this, my first job was to grab the yellow paper, the gold paper, and say, can I get my bases the same? Can I get these bases the same? No. That's the reason I didn't tell you you need your gold papers today, because they don't really apply. If we couldn't get the bases the same, what was plan B? What? Okay. We took the log of both sides.
Yeah.
We wrote LOG in front of both sides.
Yeah.
We're going to do that. We're going to take the log of both sides, except because this is base E, what type of log should I use? Natural log. So what we're going to do here is we're going to take the natural log of both sides. So this is going to be the natural log of e to the 2x equals the natural log of 3.5. Now, once you realize something on the left side, this equation becomes very easy. What base is natural log?
10.
Natural log is base E. So if I write my invisible base in here, this is the log base e of e to the 2x. Do you remember a property there? Yeah, the identity property. If this base is the same as the base on the power here, this whole side is equal to your exponent. Okay, it's equal to, natural log of base e of e is just 1. But then since we have that power, this whole side is equal to 2x. So you end up with 2x equals natural log of 3.5. How do I solve for x? Divide by 2. If it's 2 times x, divide by 2. If I divide the left by 2, divide the right by 2. And what are you going to do now? You grab your calculator and practice. As always, I suggest you practice now so you make sure you know how to use the calculator. Not that this one is exceptionally difficult, but natural log 3.5. You can hit equals, then divide by 2, or my calculator, I can just go ahead and hit divide by 2. There's the answer you're aiming for. Directions say round to the nearest thousandth. So we're looking for 3 decimal places. 0.626. Okay. Now, Xavier, did you end up just undoing your left, right, middle?
Wait, where did the e go? I looked down for 2 seconds.
Okay.
How did it leave?
Right here. I'm guessing you looked down for more than 2 seconds, but okay. So, because we took the natural log of both sides, because this natural log is base e, our identity property says when these match, it's just equal to whatever the exponent is. Okay? Now, in all honesty, if you tried to undo your left, right, middle, you wouldn't have that line at all. Because you would have had e to 2x equals 3.5, and you would have had to say natural log, or log base e, and then 3.5 equals 2x. And so it is doable to reverse your left, right, middle, but it just depends. I prefer to teach take the log of both sides. Okay. Questions on that one? Okay, let's do it. E to the x minus 2 equals 12. What is the step you're taking? Okay, can we jump right into taking the log of both sides? Yeah, because e to my power is already by itself. Yeah, now when we say take the log of both sides, I'll let you generalize as you're speaking, but because it's an e, that is the one time we need to use natural log. So the natural log of e to the x minus 2 equals the natural log of 12.
So if there's no e in the problem, we're just going to move on.
Yeah. Okay. Natural log is base e. And it's not even that you have to write that in. I just write it in for the visual effect. Because these e's match, what do we know? Okay.
So would it be x times 2?
No. It's x minus 2, so it's x minus 2. So I have x minus 2 equals the natural log of 12. If it's x minus 2, we're going to add 2. If I add 2 on one side, add 2 on the other side. X equals the natural log of 12 plus 2. Is that the same as saying the natural log of 14?
Yeah.
No. Okay. It's not the same as saying natural log of 14. It's natural log of 12 and then plus a plain old 2.
So you already know your x has to be greater than 2.
There you go. Unless natural log of 12 were to happen to be negative, but it's not. So, natural log of 12, notice I ended my parentheses, plus 2. There are some of the right answers out there, but you see mine.
I was just saying that for like multiple choice, and you'd already know.
Valid point. Yep, it's valid. Okay. 3 decimal places. 4.485. Okay, C.
These are so fun.
Okay, what's my job here? Divide by 2 because I'm trying to get
E by itself.
E by itself.
So,
Divide by 2. E to the negative x equals 10. No maybes. Just flat out 10.
the last one was -2. So we're gonna just
Okay. I've got my E by itself. So what do I do?
base E.
Take the
Base E. Oh,
Natural log.
Yeah, log. Base.
natural log of e to the negative x equals natural log of 10.
Now you can do the base E.
Okay. Now, because natural log is already base e,
Yeah.
those e's match. This is just negative x equals natural log of 10. Okay, so options include you can divide the negative 1 over, you can multiply the negative 1 over. Regardless, the easiest thing for me to say is that this is x equals negative natural log of 10. It's not going specifically on the 10, it's going on the natural log. So you either multiply it or divide it. Or just change all your signs.
So,
There's my calculator answer.
I'll have to do that.
I would do, calculate like yours, do your natural log of 10. So you probably do 10, then your natural log button, right? Hit equals, and then multiply by -1 or divide by -1. So negative 2.303.
Yeah.
Okay, last one in this section. Word problem and then work time.
Oh, wow.
You guys are getting to be pros at these. No. Okay, so to get my E by itself, since there's a plus 5, let's subtract 5. E to the 3x plus 1 equals 10. And now, what do I do? My E is by itself, so we're going to take the natural log of both sides. Natural log of e to the 3x plus 1
Base E.
equals natural log of 10. Because natural log is base e, and this is e to some power, I now have 3x plus 1 equals natural log of 10. And now, we have more solving, right? You're trying to get x by itself. If it's 3x plus 1, subtract 1. So when I write this, I'm going to write 3x as natural log of 10 minus 1. That is not natural log of 9. Okay, there we go. Found a mistake. And then, since it's 3 times x, divide all of that by 3. Now, when you do this on your calculator, honestly, it's probably best to just do this in pieces, right? natural log of 10, then minus 1, then divide by 3. Or natural log of 10 minus 1, then divide by 3. If you want to enter it all at once on your calculator, you've got to put parentheses around that numerator.
I got 0.4342.
So mine is natural log of 10 minus 1, and then divided by 3. Okay. If you did it correctly, your answer should match mine. Are we practicing with the calculators? Okay. 3 decimal places. 0.434. Okay. You got the idea there. Okay, let's look at the word problem, which you have one just like in homework. No, not necessarily just one, but I know this morning that it was exact.
They said you're going to take those off of one class.
Huh?
Didn't you say that?
Okay, a spacecraft can attain a stable orbit 300 kilometers above Earth if it reaches a velocity of 7.7 kilometers per second. The formula for a rocket's maximum velocity, v, in kilometers per second, is v equals negative 0.0098 t plus c natural log of r. The booster rocket fires for t seconds, and the velocity of the exhaust is c kilometers per second. The ratio of the mass of the rocket filled with fuel to its mass without fuel is r. Suppose a certain rocket has a mass ratio of 25, firing time of 100 seconds, and an exhaust velocity of 2.8 kilometers per second. Can the spacecraft attain a stable orbit 300 kilometers above Earth?
Wow.
And this is not where you say, okay, I read it, moving on to the next one. Absolutely not. This is not a difficult problem. Yes, there are a lot of words.
Yeah, we have to look at the keywords.
There's a lot of words. Okay, what kind of things do we see? How about an equation? V equals negative 0.0098t plus c natural log of r. That equation's kind of important, isn't it? Okay. Thoughts now?
Well, we need to figure out what v equals. So we need to plug in, find t. It's t. Oh, we'll ratio of mass. 100 seconds.
So he's trying to find the information to plug in, yes?
Yeah.
Okay. If we read right down here, and I'll come back to this other one, but there's a firing time of 100 seconds. What's that going to go into the equation for? T.
Yeah, and there's a mass ratio of
Okay.
25.
Yep, if we back up, suppose a certain rocket has a mass ratio of 25. What's that 25 going to go in for? R, because it says the ratio of the mass of the rocket filled with fuel to its mass without is R. So there's R. What else? They give me an exhaust velocity of 2.8, and it says velocity of the exhaust is C.
We're getting close.
Okay, let's fill in the equation. V equals negative 0.0098
parentheses
times T, which is
100. Oh, hey.
plus C, which is
2.8.
2.8 times natural log of R, which is 25. What's the good news here, guys? There's only one variable, and it's already solved, yes?
Yeah, put it in the calculator.
Put it in the calculator. Now, on my calculator, honestly, I can enter this all at once. Okay? If you have to do things a little backwards, you're going to have to do it in pieces. Do your multiplications and then you're adding. For me, I can just type it in. So, negative 0.0098 times 100 plus 2.8 times natural log of 25. If you do it correctly, you get this answer here. I'm going to go with 2 decimal places. 8.03. What kind of label should this have?
What do you mean?
What kind of label should go after it? Yeah. It specifically talks about velocity in kilometers per second. So this is kilometers per second.
4 miles an hour.
Now, okay, have I answered my question?
Yes.
My question-
Yes or no?
My question is, can the spacecraft attain a stable orbit 300 kilometers above Earth? It doesn't ask for a velocity, it's can it attain a stable orbit 300 kilometers above Earth? So that's a yes or no answer. But yet I have a velocity.
Well, if you take the velocity, divide that by 300 and carry it forward.
Stop there. Okay.
Wait, 7.7, where are you getting that number from?
Velocity.
Oh.
So go back and read the very first sentence of the problem, yes? When you get to this point, you're thinking, what the heck? I don't know how to answer this. Go back and reread your problem and see if it makes more sense now. A spacecraft can attain a stable orbit 300 kilometers above Earth if it reaches a velocity of 7.7 kilometers per second. Our question is, can the spacecraft attain a stable orbit? Yes, because 8.03 is greater than 7.7. So your answer would be yes, and I'm going to explain by saying the velocity of 8.03 kilometers per second is greater than 7.7 kilometers per second.
Boom. Final answer.
So, again, always make sure you go back, you read the original question, go back, make sure you reread the problem when you get to the end and you're stuck. I'm not going to necessarily work through the next one. The next one says a booster rocket for a spacecraft has a mass ratio of about 15, exhaust velocity of 2.1, firing time 30. Can the spacecraft achieve a stable orbit? Same question, different info, right? So I'll write down the answer if you tried it or you want to try it and check. But you guys can get working on homework. Your homework is lesson 7-6 in Math Excel.
What do you think I'm going to have to do? Run, like,